Cool. Now we get to look at differentials. Well, we've been used to finding derivatives, which you know is dy over dx, and that's equal to our derivative. Now, our differential is basically getting dy by itself. So to get dy by itself, we got to multiply both sides by dx. So we take that over there, and we get our differential. This is our differential. So once again, you basically find the derivative of your function. So you get dy over dx equals 2x in this case. Multiply both sides by dx, and we get this here. And that's really all it is. So here's our function. Here's our derivative, our differential. You just got to multiply both sides by dx. Now keep in mind when you have variables times variables, you got to do your product rule. So we do our product rule here. We get this here. Then you got to multiply both sides by dx. Since we have multiple terms, we got to put the whole right side in parentheses, all multiplied by dx. And similarly down here. Now, this would be just multiplied by dx, but it's really dx over 1, so it puts our dx up on top. So here we're looking for our differential. Well, basically, you got to do your derivative, put your exponent in front, decrease your exponent by 1, put your exponent in front, decrease your exponent by 1, and then you got to just multiply both sides by dx. Woo! There we go! That's your differential. Well, same idea over here. Oh, but keep in mind you have variables times variables. Product rule. Derivative of the first times the second plus the first times the derivative of the second. There it is. Oh, there. Wow, that was freaky. Oh, made it. But now to get the differential, got to multiply both sides by dx. There it is. Once again, we got to have the whole right side in parentheses multiplied by dx. Well, sometimes you're looking for your differential, but you're also looking for the actual change in your y value. Well, here we have our function. We're looking for our differential when x is 1 and our delta or dx is 0.01. We want to go ahead and compare our differential with our delta y. Well, to do the differential, you got to do your derivative. Well, there's our derivative. Oh, we got to get dy by itself, so multiply both sides by dx. There we go. But we have a particular value for x, so we're going to have to plug that in for our x, so it'd be a 2 times a 1. And we know what dx is. That's 1/100th. We plug that in. Oh, we get 2 times 1/100th, or 2/100ths. Then we also want to compare that for dy. Well, not dy, sorry, delta y. Delta, remember, means change. So we're looking in the change in the two y values between our 2 points. And you're like, 2 points? I don't see 2 points. I know x is 1, and if I plug in 1, I get 1. So that's my first point. Yes, that's your first point. But we have another point here. Our other point is 1/100th over, because it says our change in our x. So we got to go 1/100th over from 1. So that means it's 1.01. So 1 and 1/100th. Oh, if that's my x, to figure out my y, all I have to do is plug that in. Oh, 1.01, and then I got to square that into my function. There we go. Well, delta y is just a change in my y value. So I'm going to take my big Y value minus my second Y value, and I get this. Really, it's the second Y value minus the first Y value, so I get this here. Now, you'll notice these are very similar. They should be very similar, assuming your dx or your delta x is relatively small.